Hey there, everybody. Welcome back. We're in Calculus 3, fall of 2022. It calls the Sequoias. This is spherical triple integrals. We're in 14.6 in Anton's 11th edition, I believe. So I just wanted to, since we're doing spherical, I wanted to recap the equations that shift from rectangle to spherical and back again. So rho squared, which is our radius of the sphere, is x squared plus y squared plus z squared, where rho is the radius. We have tangent of theta equals y over x, and cosine of phi equals z over the square root of x squared plus y squared plus z squared. Also, another way of thinking about it is z over rho. And then our x, y, and z, rho sine phi cosine theta for x, rho sine phi sine theta for y, and rho cosine phi for z. You can see that from these two. And the limits of integration are 0 to 2 pi for a full sphere. For theta, phi goes from 0 to pi. Remember, it starts at the top, and the angle that it makes downward is phi. And then we got rho is greater than or equal to 0 up to some value rho. So probably 0 is less than or equal to rho, less than or equal to rho naught. In 14.7, we study the Jacobian. We'll see the derivation in a simpler form for dv. In spherical, it's rho squared sine phi times d rho d phi d theta. Rho squared sine phi is called the correction factor, just as r is called the correction factor for cylindrical. So our triple integral for f of rho, theta, and phi dv, we can write it with rho squared sine phi d rho d phi d theta. So let's look at some sample shapes. I think it's kind of helpful. If we have a portion of a sphere in the first quadrant, so it's got like a fixed radius, sphere's got a radius of rho naught. So that's rho naught, that's rho naught for z, and y's got rho naught there. So we're only sweeping in theta pi over 2, 0 to pi over 2, because it's from the x-axis to the y-axis. Phi starts at here and rotates down to the y-axis. That's only pi over 2, so 0 to pi over 2. And radially, we're going outward from 0 to rho naught. Okay. What the function is doesn't matter. That's the setup. dv again is that rho squared sine phi d rho d phi d theta. Let's look at a cone wedge cut from a sphere. So we got a full sphere and we've got a cone that intersects it. And we're just doing the volume that's inside, like the overlap of a cone in a sphere. Looks like an ice cream cone. It makes an angle phi naught going from the z-axis down to the sides. Since it is a cone, that radial bit is constant. So r is going to go from 0 to rho naught. Not r. Rho is going to go from 0 to rho naught. Phi will go from 0 to phi naught. And we sweep the full circle in the xy plane. So 0 to 2 pi. Got 3 more we're going to look at. We had a cone. What about a hollowed out cone? Where there's like, we have an outer side, but then we've scooped out the inside, the inside, and it goes all the way to the surface, comes out like that, cutting out the entire surface. So the picture's not very good. But we do have 2 angles. It goes to phi 1 in the first place and then phi 2 on the second cone. So that's what we're going to integrate for along theta. We're really going, or not theta, phi. We're really going from phi 1 to phi 2. So phi1 to phi2. Again, our radius is out to the edge of the sphere, which the sphere has a radius of rho naught. So 0 to rho naught, and we've got the full circle in the xy plane. So 0 to 2 pi. What if we chop off the top of the cone, make it flat? Still, that phi naught will be our angle. Let's say that top of the cone is at z equals a. I made a little triangle depicting this triangle right here. So a is the vertical height, rho is the distance along the side. This angle here is the same as, that's the angle phi sweeping down. So that's phi naught. So cosine phi from the triangle is a over rho. Well, I need the rho naught or the phi naught in there. So we solve for rho. It's a over cosine phi naught, but that's secant. So we're going to go 0 to a secant phi. Then we'll go from 0 to phi naught. Then we'll go from 0 to 2 pi. Okay. I'm going to change that. We're just sweeping out the full bit. Each triangle is getting a different one. If we do a hollow sphere where there's a like an egg, but egg isn't really spherical, is it? We've got an inner radius rho 1 and an outer radius rho 2. So that'll be our limits of integration on radius rho. Full sphere though is 0 to pi on phi and 0 to 2 pi on theta. So that'll be it for some shapes that are common using spherical. Catch you in the example videos next. Peace.